We're good? All right. Thank you for helping me get set up. Hello, everyone. I'm here to talk about building NFT APIs on the Graph protocol. And this is a workshop. I kind of intended to have a little more time, but we're going to actually walk through how to do this. And I've also created a open source GitHub repo for anyone that wants to actually build this themselves and maybe take a little more time. But the idea here is that we want to find a smart contract that has been deployed to a network. We want to index data out of that contract, and we want to kind of make it queryable through some API endpoint. And we're going to be using the Graph protocol. So the Graph is a indexing and querying protocol for getting data from blockchain applications, or I would say from blockchain networks. There is a couple of different ways that you can build subgraphs. We have a hosted service and a decentralized network. And today we're going to be kind of walking through how all this stuff works. So the reason that the Graph exists, well, when you build out applications in the traditional, I would say like quote unquote like Web 2 space, or you're maybe dealing with traditional databases, databases like SQL and NoSQL databases are optimized for both read and write operations, whereas blockchains are mainly optimized, and all of the technology and all of the innovation is typically happening around the transactions and transaction times, transaction costs, optimizing there. But reading this data isn't quite so simple, I would say. So if you want to read data from a application or some type of smart contract that's been deployed to a network, you might have a couple of functions that have some type of selection set that you can retrieve that data. But if you want anything beyond something basic, if you need something like filtering, searching, full text search, querying, things like relational data, all of that stuff, a lot of times developers will end up building out an indexing server where you kind of take all of this data, you store it in a database, and you serve it up via some API endpoint. The Graph offers kind of a decentralized way to do that, but also we have a protocol that enables people to kind of participate in the network, and we can verify that the data that is being returned is actually correct. So we have about 15 or so minutes, and I want to kind of show how this all works. If you would like to follow along with this now or later, you can go to my GitHub, and it's github.com/Dabit3. The first workshop, or the first code base that you'll see there, is this ETH Denver workshop. And I'm choosing the CryptoCoven NFT project to kind of build on, but this actual code base could work for almost anything. So if there's any NFT project that's been deployed to any of the 30 or so networks that we support, you can kind of take this code base and build out your own APIs on top of any of those smart contracts. And obviously this doesn't only apply to NFTs. A lot of DeFi projects like Uniswap are using the Graph, gaming, pretty much anything in the Web3 space. So what I'm going to do is start off just by building out this entire thing end to end and deploying it. So what we want to do is we want to first install the Graph CLI, and I already have that installed. So this is a tool that allows you to create boilerplate projects and also just have tooling and stuff for your project. So once you've built your API, you can kind of deploy it from the command line using the Graph CLI. So once we have the Graph CLI installed, we can initialize a new boilerplate project. So what we kind of want to do is kind of have all the different pieces that we need to get started building, and we can kind of scaffold out some example code for us to kind of then update. And we're going to be using the graph init command. So graph init just initializes a new subgraph, and this subgraph boilerplate will be what we can use to build upon. And we can pass in a few different flags. So we want to pass in the contract address for the CryptoCoven NFT that's been deployed to Ethereum. So I have a link to that here, and all you would need to do for any of these APIs to build any of these APIs, you just need to kind of have that contract address. So we're going to say graph init, and we're going to pass in the contract address along with a couple of other flags, and this will initialize kind of like a boilerplate project for us. Now, as we're doing this, we first also need to go into the Graph dashboard and create an example project for us to deploy to. So I'm going to go to my dashboard here in the graph.com, and I'm going to click Add Subgraph, and I'm going to call this like ETH Denver API. And this will be a CryptoCoven API. And this will go ahead and create this subgraph for us. And once this is created, we can go ahead and initialize our local project. And my internet's a little slow because I'm actually connected to my hotspot because for some reason the Wi-Fi isn't working on my computer. So I'll give this a couple of seconds. Oh, yeah, sure. There we go, yeah. And while that's saving, I can go ahead actually back to my command line and just assume that's worked. And it's going to walk us through a couple of options. I'm going to choose Ethereum for the protocol. We support a couple of different networks, EVM compatible, Near, and in the near future, Cosmos and Solana. I'm going to choose the hosted service. For the subgraph name, I'm going to put in my username / the name of the API I just created. And this will go ahead and create it in a directory. I can choose Ethereum mainnet, the contract address, and the token name. Now, this is going to go ahead and create a boilerplate code base for us. And this might take a few seconds because I have a slow internet connection. So it looks like we have a few files here that we can go ahead and get started with, though. So when you scaffold out a new Graph Cli API with the graph, you are going to be starting with a couple of different files and folders to kind of get you started. But there's really three main things that you need to know when you're building subgraphs. You need to have your GraphQL schema defined, and this is kind of your data model. So if you've ever modeled data in pretty much any language, any type language, it's very similar to that. And if you've ever used GraphQL, then you're probably familiar with GraphQL. So you model your data in your GraphQL schema. You have a main configuration file, which is the subgraph.yaml. This defines the things like the contract addresses, the different events that you would like to index, as well as the entities that you've defined in your GraphQL schema, as well as a start block so you don't have to start indexing the network from the Genesis block. And then finally, the SRC folder has a file called mappings. And these are the function handlers that are going to be invoked whenever one of these events gets fired. And we're going to kind of walk through how this works. So with those three things in mind, let me try this one more time here. Oh, it looks like that was actually created. So let me go to my subgraphs. Okay, there we go. All right. So with that in mind, kind of like walking through those three pieces, let's go ahead and fill these pieces out. So the first thing I'm going to do probably is go ahead and define my data model. And the data model is going to be something like this, where we have a token, and the token is going to be an NFT, non-fungible token. And by default, from the contract, we can get the token ID, and we can get the owner of that token. But other than that, we don't really have any other information. But from within the subgraph mapping, we can actually call out to both IPFS as well as the graph node, and also the network itself. So we can call the contract, get information, we can call back to the graph node, and we can also talk to IPFS. So using those three different HTTP calls, we can actually take the ID and actually get all the other metadata that we would like off of IPFS. So with that being said, I'm going to go ahead and copy this GraphQL schema and go ahead and do the token. Whoops, this is the wrong. There we go. So the token is going to have an ID, it's going to have a token URI, it's going to have a few other pieces of metadata like the image, the name, and the description. And we're going to also have a user, and then we're going to be able to actually map a relationship between the token and the user and vice versa. So this way we can actually query for tokens and their users, and we can also query for users and their tokens. And then finally, we want to add full text search. So here, with this definition that I have here, we can define which actual entity that we want to make searchable. So we have that token entity, and then we can define the fields that we want to make searchable. So here we have all these different pieces of metadata. I'm essentially just kind of like grabbing a handful of those and putting them there. So that's all we need for our GraphQL schema. The next thing that we'll go and update is our subgraph.yaml. So for our entities, we can just update this to be the token and the user. And for the event handlers, the only event that we're going to be dealing with in this example is the transfer event. And this is going to fire when a token is created or minted, but it's also going to fire when someone transfers that. So this kind of keeps up to date all the tokens that are available. And then finally, we want to go ahead and define the start block. And this is when the contract had its first token created. And this is essentially going to be where we start indexing. So I can say start block, put that there. All right, so it looks like our subgraph configuration is done. And I can go to the terminal and get some boilerplate code that we can now use in our mappings based on our GraphQL schema and our subgraph.yaml by running graph codegen. And this is going to introspect our GraphQL schema. It's going to give us some nice types as well as some APIs for interacting both with the graph node as well as the contract itself. And it's going to generate those for us in a folder called generated, and we can now use those in our mappings. So I'm going to go ahead and delete those, and the last thing we need to do is write the mappings. And this is kind of the actual business logic that you're going to have to write as a developer. Like everything else is just configuration stuff. But here you're actually saying, OK, this is what I want to do with the code. I want to actually take this token ID. I want to call this contract. I want to get this information. I want to take this token object, and I want to append these different properties to it. And then we want to save it to the graph node. And then from there, it would be made available. So I'm going to go ahead and start by just pasting in these imports. These are the APIs as well as the types for interacting with the contract itself. And then these are APIs for interacting with the graph node, which is kind of like you could think of as the database where all of this is stored. And then we also have the IPFS hash, and you can get the base URI for almost any ERC721 by going to the contract, and they have a function called getBaseURI, and this is kind of where you would get that. And kind of using this IPFS hash, we can say like this IPFS hash / tokenid.json, get the metadata, append it to our object, and save it to the graph node. And that's what's going to be happening in this very, very long function. And again, like this is probably not the right time, 20 minutes for a workshop like this for me to actually walk through all of this code. But what I can tell you is happening is in this function right here, this handle transfer, every time a function is transferred from one user to another or one is minted, this function is fired. And then this is where we're going to be actually storing that information in the graph node. So we first check to see if a token exists. If it does exist, all we do is update the owner because all of the metadata should be the same. If it doesn't exist, we kind of go through and we construct this object with all the different metadata by talking to IPFS, by calling this IPFS API that we have from the Graph TypeScript library. So if I save that file, we're actually done with everything, and I can go here and I can go ahead and run a build. So I should be able to run graph build to kind of make sure everything is configured properly. And if this is configured properly, we can now deploy this and test it out. So the build's completed. I can now go to the CLI, and I need to deploy this to that project that I created in the graph dashboard. And to do that, I need to first authenticate so no one can kind of deploy to my, app. And all we need to do is just like copy this access token. And I know this is public, but I'm okay with that. This is a test account. I'm going to go ahead and say graph auth, and it's going to go ahead and authenticate. And then now I can actually deploy from this session. So I can say yarn deploy. And this is going to go ahead and deploy the API. And we should be able to test it out. Now, this is running on my phone's Wi-Fi, so I'm not sure how long this is going to take, but it seems to be working all right. All right, that was actually fast. So if I go back to this and I refresh, we should see we have a nice GraphQL text editor or graphical editor for us to start sending queries. And by default, we have kind of an example query. We see that we're getting our information back. And we can say, okay, I want to get the image, I want to get the name, and I want to get the description. And we're getting all the information back. And if I kind of like take this image and I paste it here, whoops, then we should get a cryptocurrency. So it looks like our API is working. The next thing we might want to do is like, oh, okay, I want to now add full text search to my app. So I can now invoke that query that we created earlier called, I think it was like Coven search. And I can pass in the text that I would like to search. So here I'm going to say something like Nix, I guess. And we're going to only get the cryptocurrencies with the name Nix. And I'll just define the data that I want returned. And there we go. We have that one that came back. A couple of other queries that you might want to do would be stuff like pagination. So here I'm just like saying I'm going to skip the first 100 and I'm going to kind of like get that second page. Also, you can do stuff like ordering. So here I might want to say I'm going to order by the updated timestamp, so we can kind of have like a nice UI that shows the most recently created and updated, the most recently created and transferred NFTs. So that query is coming back. And then maybe there's one more query that we haven't checked out. Yeah, so there's also filtering. So in addition to the full text search, you might want to say something like, okay, I only want to get the NFT crypto covens that have this sign, which is Capricorn, and then we're getting all that back. And the beauty of GraphQL is that you can define the data that you want return. So here we can go into this graphical edit, the GraphQL schema introspection on the right, and we can see all these different properties that are available, and we can define the ones that we want to bring back, and therefore you're kind of like saving on the bandwidth, and therefore you kind of have like a more optimized API that is more performant in areas where you might have limited internet bandwidth and stuff like that. So that's it. We kind of built an entire GraphQL API from scratch in about 20 minutes. And if you've ever tried to build your own indexer, you realize the pain and suffering that something like this might help you with. So I would encourage you to check it out and check out this workshop, check out the Graph docs. We're on Twitter at the Graph Protocol. And yeah, there's a bunch of tutorials and stuff out there. So check all that stuff out. And if anyone has any questions, I'll go ahead and start answering those now. Yes. The only networks, the question was like we called IPFS from within the graph node mapping. The only networks that we allow calls to be made to are IPFS, the graph node itself, and also the network for which your API is deployed to. So in our case, it would be Ethereum mainnet. So you can like call the contract and get information from there. But other than that, no, you can't just make an arbitrary like HTTP call. Yeah. Yes? Yes. Yeah, so the Graph network basically has a network of indexers, and if you want to become an indexer, you stake GRT, Graph tokens, and you're now operating a node on the network. And if you are serving like the wrong improper data, you get slashed. So therefore, that's kind of like where that data verifiability comes, because if you call a blockchain network directly through an RPC that you own, you know that data is proper. But if you're running your own indexer, or you're kind of like calling a centralized indexer, you don't know if that data is verified. So that's kind of the whole idea around how the network works.
Do you support event triggers or webhooks based on specific?
So GraphQL has this idea of like GraphQL subscriptions, which are really nice. And we actually support subscriptions, but not, I would say, in a way that it's currently production ready. Some people are using them, but right now we don't support subscriptions on the client. The Graph node itself, like once you deploy, it will have listeners set up and it will continue to index new data that's coming through. But on your client-side application, you might have to set up some type of your own event listener and kind of like either refetch or maybe just deal with that data as it's coming through yourself.
I don't know if I missed this in the beginning, but do you need GRT to deploy a subgraph and to query it? It's all.
No, there's a couple of ways. Just following the tutorial here that you can deploy and run it in production, you should be fine.
So, so you never need GRT to do any querying.
Well,
it's just for
so there's like the service that we use is the hosted service. So this is kind of, I would say, not the decentralized network. So if you wanted that data verifiability, then you would need GRT to deploy and then use your API on the network.
Okay,
so,
thank you.
Sure.
Hey, you had mentioned that these indexers are running. Could you go a little bit into like the incentive models on how they are rewarded for running these indexers?
Can you repeat the main part of the question? I did hear you're kind of asking about indexers.
Yeah, so someone is staking their GRT and they're running an indexer. How are they rewarded for doing so?
Okay, yeah. So you get rewarded as an indexer with a combination of the query fees that the developer that's kind of like using that API is paying, along with network-wide inflation. So there's like a token inflation that gets distributed to all the network participants that are running indexers. And you can also be a non-technical person and delegate tokens to an indexer, so you don't have to kind of be a developer to participate in the network.
Anybody else?
All right, thank you so much.
So a couple things real quick. First of all,